so much, Dr. Gijs. Welcome everybody to today's session. We only have a few small house rules for today. We would like to ask you to please keep your cameras muted to save data and bandwidth. Also to ask you to please mute your microphones, keep all the background noise to minimum. If anybody has questions at any point in time, please feel free to raise your hand. And then over to you, Dr. Gijs.
There we go. Thank you very much. So welcome everybody to, this is again the very first. So we kind of go through M1, M2, M3, and then we repeat it a couple of times. So it's really good to have a lot of faces that I know. I can recognize the voice. Let me just put my camera here. There we go. A lot of faces that we recognize. I see there's a lot of new faces. But it's always good. It's always good to be part of this community, and if nothing else, it's for the sharing of ideas, sharing of things that we're doing with our classes, and really as a motivation for all the new coaches amongst us. We never end learning. We never stop learning, and so in the session at 4 o'clock, we're going to launch a new competition, and we're very excited about that. But you know, every journey of robotics has got to start somewhere. So I guess it's on the 10th of May, 2022, that maybe some of you are starting your first journey. Some of us have been here far too long to remember, but nonetheless, it's really exciting, and we're always learning something new. And I think that's the important, to have a learning spirit and to be open for learning and open for sharing as well. So. All right, so the first hour is we're going to do the basics, and there are 4 units. We only have 3 days, so we're going to do unit 1, and then 2 and 3 tomorrow, and then unit 4 on Thursday. And then after, in the next session, we're going to introduce you to a robotics competition, a bit with a difference, and we'd love you to join us there. Thank you to Casper for also the production and for always being here, and welcome to everybody new. So how it works, I'm going to work through a presentation. It's not intended to be a one-way, it's just an introduction and a sharing of ideas, and there's 3 parts to it, and I will pause in between if you have questions to ask, and then we can share ideas. And then now Tumelo is sitting in the... Okay, so Tumelo can't talk. The content of all of this is available on the UNISA MOOC portal. So if you need any help accessing the UNISA MOOC, please I'll give you the email address at the end, and you can set up an appointment with Tumelo, and he will guide you through everything and show you where everything is. Okay. All right. So let's just share the presentation. Let's start. And as always, I am sharing my screen. So there we go. So I just need...
There we go. I can see Dr. Gijs.
Ah, awesome. Thank you very much. All right. So really welcome to the basics. We call it M1. All the content is available on the MOOC portal for all the 4 units, and you are welcome to go and have a look at it there. So the focus for these robotics is for grades 4 to grade 10. And today we're going to do some building. How do you build a robot? What is expected when you build a robot? Now, I know for many of you, you've never built a robot, but you know what? There's always a first time. It's the first time to build a robot. I've introduced most of the members of the team. And I see Anzani's just come in, and we'd love to hear your questions and answers at the end. And again, these are the email addresses. If you've got MOOC queries or general queries, Tumelo and Anzani are right there, and they're happy to guide you through the whole process. All right. And this is normally Tumelo's slide, and it says the M1, all the MOOCs are 0 rated. So once you get in, it's on our expense, so you're welcome to go and look around there. But we do ask you to be part of our research and evaluation to create a better MOOC experience as we go along. And Tumelo will explain how to log in and how all the sites that are available. And that's what it looks like, but Tamela will help you if you need any assistance there. Okay, so let's get to the content. The components of building a robot. What does a robot look like? So I've got a little robot standing here, and I was asked, don't show the complex ones because so I'll show you all my little robots here that I have here, and then we can kind of work through it. It's a journey. This is a journey. There are 4 sessions, and the journey doesn't always end. So in the olden days, this is how we used to do workshops in the science center. Yeah, but now we're online. So our purpose is really to equip all the coaches, educators. We'd love to hear your questions, and we would also love to share with you the answers. All right. So what is this robotics thing? This robotics is kind of the joining of engineering and of programming, and then 21st century skills, and that kind of happens in between. So the in between the engineering and the programming is then the 21st century skills. And for now, we're just going to do motorized robots. So a little robot with front wheels, back wheels, and a little brain to do the programming. For this course, we build robots using an EV3 kit. You can use lab programming for that, or you can use the EV3 kit with the EV3 classroom, which is more like the Scratch kind of programming. The new kit on the block is the Spike Prime robot, and that also uses Scratch programming. So either of those options are kind of what we use to demonstrate here. There are lots of resources, and we use them and we share them. If you've got anyone in particular that you really enjoy using, please share and let us know. These are the ones we use, and we're very open to sharing everything we find. Okay, so just to kind of pause, take a sip of tea, and think now, so what is a robot? And a robot, in the most general terms, can either stand still, which means it's fixed, or it's mobile. Okay, so it moves around. The funnest robots are the ones that move around, of course. Okay. Yes, you get robots that go under the water, which is awesome, and that go on top of the land. That's kind of where we are. And then airborne are the drones that we see around us. And there's some interesting work on swarm robotics, where the robots actually act as a swarm, like a swarm of flies, swarm of locusts. So that's a whole different topic. So we're sticking here to robot, to mobile, to terrestrial, and we're sticking to wheeled robots. There's a lot of cool examples of legged robots. Yeah, it's interesting. It's different, and we'll get to that hopefully by M2. All right. So this is just general knowledge. This is if you go and look on the internet, you can Google what is the cutest robot. Well, apparently Wall-E is the cutest robot. It has a 44.46 cuteness rating, whatever that means. Okay, but these are all the other little robots that are popular, and so they've introduced the cuteness of robots. So that's one way of looking at robots. If you think they're cute. R2D2's got a cute name, but that's just my opinion. Then they ask, what is the most popular robot? So not cutest, but popular robot. And I've met Sophia. She is phenomenal, and it plays with your brain. It plays with your brain to look at her and know that she's not she, but a robot. Okay, and so for you, go and watch some videos, go and see what's out there. So that's the one robot that I have met, Sophia. Mind-blowing, absolutely mind-blowing. And the fact that she had a designer dress on was even more amazing. She was at a function. But I think if you want to kind of inspire your learners, go and look what Boston Dynamics are doing. Really, really impressive stuff. And so whilst on the one hand we are doing, like building a robot and programming a robot, it's good to keep a vision ahead of us to say, so what are we going to? Remember, we're equipping our learners for their future, not for our future. We are equipping our learners for their future. Okay. So what we are focusing on is the EV3 kit. I can also just take a step back and say, the kit that you get, you can build these robots, but what you actually want to do is you want to develop a frame of reference. Okay, and as we go through the lessons, I'll show you how you evolve. You equip the learners with a basic frame of reference, and then they need to start designing. And once they start designing their own robots and their own attachments, I think that's when the learning starts and the creativity starts and the innovation starts. So one kit, gazillion robots, and all the robots that your learners will design and invent for themselves. Okay, so one kit, this is the EV3 kit. You see all the pieces are grays and whites and blacks. The Spike Prime is definitely more colorful. But nonetheless, this is a wheeled robot. It's got wheels. It's got a caster wheel at the back. This is a wheeled robot, also a wheeled robot. The drive wheels are in front to hold. And so we continue. All right. So let me just stop sharing here. Okay. And I'm just going to pause a minute. Okay. I'm just checking. Everybody okay? Everybody is fine with the process, so I can continue then. And now, okay, so this one, I just want to share my next one. You know.
It's late in the afternoon.
Yes, that's for sure. Okay. Yeah. All right. So yes, we can see the slideshow again.
Yes, it's coming through. Yes, I can see it.
Okay, cool. All right. So for unit 1, all we're doing is focusing on the wheeled robots. And so, oh darn, I was going to show you some of these robots. I'll show it after the session. Okay. So different robots have different wheels, different sizes, different chassis. But for unit 1, it's really focusing on the function of the robot. Okay. And then we need to obviously adapt, whether it's a tall robot or a flat robot. The learners really do need to know what the components are. They're not a thing in another thing. And if you really want to get me thingy, then you talk about a thingy. So it's wheels and axles and sensors. And so that's the one thing. You've got to have parts or components that you build your robot. But the other one is it's got to be sturdy. And all too often, I get to robotics competitions and the learners pick up their robot and the whole thing falls apart. And that for me is like so not okay. All right. You as coaches need to make sure that the robot is sturdy and rigid in structure. Okay. The power source of the robot, all robots have got a power bank, which can be recharged. I just want to also pause here and say, yes, you can use these pen-light batteries, but it's going to cost you an absolute fortune. These robots eat the power. They really eat batteries. And so I would really, if you haven't got a battery pack, please let us know. Or if you don't know what a battery pack is, please send us an email so we can just explain to you where the battery pack is. But all robots must have a function. They must be built for some reason, okay? And so this is form and function. Usually your function determines the form of your robot. Okay, so if you go onto the MOOC portal and Unit 1, there's some building objectives. And so it really is to expose your learners to building objectives, different objectives. Remember, the whole focus is we're trying not just to plow through the lessons, but actually that your students or your learners learn something about what the options are. So there's a really cool document called Constructopedia. And now with that said, I wonder whether it's uploaded. If it's not, I'll put it up on the MOOC portal. So that is about mounting the brain of your robot differently, different wheels, different tires, but really for the learners to get an idea of how to build a robot. Please do not just give them a kit and say build a robot. That is not constructive learning. You've got to guide them. You are the coach. Remember, you are coaching them. For EV3, the Riley Rover is the easiest robot. Yeah, it just is a really easy structure. Okay, and then you've got to actually build them. So build the robot, build all these robots. These are the activities that you do in Unit 1. All right. Okay, so the engineering is the Unit 1. Then we'll do some programming tomorrow is Unit 2. Then we'll throw in the 21st century skills. And then on Thursday we'll do some designing of attachments. Okay, these are the kind of robots you can build with these things. And these are the pieces. So obviously everything is sorted. Chaos is not good when you build, because then you're forever looking for things. You have to be organized so that you can follow building instructions. All right. So let's get to, so what are we building? Well, we're building a robot. This is the underside of Angel. You can see it's quite complex. And I'll show you the process, how the learners got to this design. But it's really about all the technology terms that you know about, the center of gravity, the weight distribution, how to balance a robot, the backlash efficiency, the designing process. That is all on the M2. So basically, if you have a robot, then this, what I'm talking about is the brain. This is the brain. This is where you upload all your programs. This is the battery pack that you must keep charged. And if you have a team that meets on a particular afternoon, then you should have some learners who are charging your battery pack for you in the morning. So it packs all day. And then your output are your motors, so it makes the motor move, a robot move, and the sensors we're going to get to in M2, which will be next week. Okay, the hub and the motors look a little bit different on the Spike Prime, but it's still got the basic functions. It's still exactly as functional as the EV3. Okay, and again, all the pieces are a little bit more colorful, but they're nonetheless there. So just a thing, if you want to know if there's an axle and you want to know how long it is, you measure it against the length of a beam and you count the number of holes that it measures up to. So this axle measures up to the 12th hole, so it is a 12 axle. Okay, these are the lengths down the side here, and this times on the side is how many of them should be in your kit. Okay, and I'll get to it later, but I do need to highlight, if you have teams that are not going to take ownership, they're messing it up for the teams that come afterwards. Nobody likes building a robot with a single wheel. Okay, it's not okay. It's just not okay. All right. So there's all the correct pieces. There are names for these pieces. There's actually a list of pieces. And so we avoid thingies and other thingies. All right. Okay, so what robot to build? Well, I don't know whether you've started looking around, but there is a plethora of lessons. If you've got a Spike, you go to Spike lessons. EV3 lessons are really cool. There's building instructions, there's videos. The choice is yours. But I would say a Riley rover for an EV3 and a driving base for the Spike Prime as driving base. But there are building instructions. Okay, and so there's more, and everybody wants to build their really cool robot. So there's no shortage. This is the Droid Bot, which is a nice good structure, nice solid structure, because it's got the wheels also inside the frames. Okay. So how do you follow building instructions? Well, read them like this. No words. So you take an axle. You take one axle of length 4 plus a connector, and then you put that one into there, and then you put it into there, and you push that into there. No words needed. Okay. And this is step number 3. Okay. You just follow the instructions. But that is easier said than done. I can guarantee you. Okay. So this one is, you get one of these, you turn the model upside down, and you stick it on at the bottom here. Okay, again, easier said than done. Learners really need to learn, A, to follow instructions, and B, to be able to interpret a 2-dimensional building instructions in 3 dimensions, because they're building in 3 dimensions. Okay, yes, there are YouTube videos available piece by piece that you can watch as an alternative to following building instructions. And there's a whole lot of building. You just type in Spike Prime building instructions. So there's quite a lot. You will find your own favorite one. My favorite for EV3s is still Builder Dude 35. And then, of course, there's the classroom activities for busy teachers. So there's everything in the book. there are a lot of lessons, a lot of ways to build, and so you've got the driving base, and then you've got the tools and the accessories as well. Okay. But why do we teach learners to build? Well, first and foremost, they need to learn to think in 3 dimensions and follow instructions. But there's a vocabulary that they're learning. Okay, so it's not always obvious, but they do need to be able to explain how they built the robot. And out of every lesson, there should be a time when they kind of, now I'll explain to you, and you do need to include that in your learning as well. They need to be able to explain how they've built it. And every now and again, it's good to throw in a problem and ask them to solve it. And they need to be able to, as a team, solve the problem. No solo flying, please, in the robotics. Never solo. Okay, this is the Constructopedia. This is the link for it if you want to download it. But it's just the chassis, and because you need to then add the wheels and the wires to make it actually move. But we'll do that tomorrow. Okay, so let me just stop here. All right, this is now me and my sharing. Okay, so I'm just gonna pause for 1 minute. I want to show you some robots. So this is just the normal Riley rover. Okay, so it's got the 2 wheels. It's got the brain, and then it's got to be connected. So these are the wires here. There we go. And so these wires are put into the motors, and then they are connected to ports B and C. So B and C are my wheels, and it's just a convention, especially if you have a large class of learners. So if you have a robot like this, the wheels are in the front because they need traction to go forward, and you pretend that you're driving. So if you're driving, the wheel on my left-hand side will be port B, and then C is the right-hand side. There's no right or wrong, but if you're in a large class and you need to debug code quickly, you need to be able to see the errors. And so that just allows you to very quickly see something. Okay, so this is straightforward. When you put the wires in, there's a little lippy on it, so you've got to actually push the lip down and then push it in. So it looks like this. Where am I? There we go. All right. Please do not just pull out the wire. Okay, it breaks. Okay, and then when you put it into port B over here, there you go. You put it in, it's got to go click. Oh my word. There we go. Okay, so, and then you know that the robot is connected. Okay, and when I show you tomorrow on the programming, you can actually see on the programming palette whether all the wires are connected correctly. So for now, we're just doing 2 wires, B and C, just to get the motor ports working. Okay, so this is really a Riley rover. I cannot remember whether this is actually built from a building base or whether this has just been put together. I will check that out. But it's just a little basic robot. Again, it's just got the hub and the wheels, and then at the back it's got a balance, so the robot actually moves forward. It doesn't look like much, but it's a robot. All right. So so what happens when you as you teach, there's actually a progress with your learners, how you progress through the building of a robot. And I start like this. This is just a normal Riley rover. We do some basic navigation with it. The next structure that I usually teach my learners are the rigid structure. So you'll see this robot has a frame around it. It's just a more rigid structure. And so that's kind of the next step. But what I do want to show you, you're going to progress your learners through this. But you are not going to build anything. Okay, so please do not build your children's robots. You are the coach. You are the coach. You do not build their robots. Okay. What you want to do by exposing them to different building instructions is you want them to start being independent thinkers. Okay. And I'll show you So this is Mario. This is the Mario robot that we eventually, this team has been working for 5 years, okay? So you can see they start designing their own robots. They start designing their own features. They start designing what they need from their robot, okay? This is what you must keep in the back of your mind. You want learners to be able to design their own robots, okay? And so building instructions for a frame of reference all the way, okay? You build a robot, you program it, you make it do something. If it doesn't quite work, you get them to modify it. Remember, this is a forgiving system. If it doesn't work, you can change it. It's no right or wrong. And often in competitions, the learners will present to the engineers. And one of the questions the engineers ask is this for your first ever robot? Now, it's good to say no. No, we designed one, we built one, we tried it, it didn't work, so we changed it. And then we changed this, and then we changed that, and then we changed the next thing. It's fine. It's fine to change. It's fine to learn, and it's good to learn. All right. So these are all my little baby robots. So just as an exercise, the team, the Hey That's Us team, then decided to try and build Mario with a Spike Prime kit, and it's just as effective. All right. That comes with the practice. All right. Let me do the last presentation quickly, and then we can have some questions. So let me show you the last session. Okay. Are we here, Casper?
Yes.
Okay.
Yes, I can see.
Thank you. All right. So this is just this is for you as the coaches. There does need to be classroom management, okay, and you need to manage the learners' teamwork as well, because this is part of the skills that you as the coach are developing. All right. So one of the first things is you need to take care of your robotics kit, and having pieces lying all over the place, that is not okay. All over here, all lying over here, not accounted for, all democard, everything. What bothers me as well is that this brain is being charged by a wire that's being charged from down there, and it's balancing on the laptop. Now let that thing fall, then there's no robot, there's no brain. Not okay. It is not your stuff. It doesn't, the learners have not, whether they've bought it or not is also not important. It's not their stuff, and they are just then diminishing the opportunities of learners further down the road. So at all times, just by the way, these little elastic bands are hard to come by. They shouldn't be lying around. They should be neatly in your kit, in a, maybe even in a Ziploc bag. Okay, all your axles together, all your wheels together, not like this. Please not. There's no fun in incomplete kits. There is so here's one of the things. There must be enough time at the end of your class that you present for cleanup. You are not cleaning up. As coach, you are not cleaning up. If the learners are using the robotics equipment, they are responsible for tidying up. And as they received it, they need to hand it in. All right. That laptop, you need to save that program. You need to shut down the program, and you need to make backups. Those kits need to be sorted neatly. All the axles together, all the beams together, all the connectors together. No, this is not okay. Only once do you get caught without anybody in the class and you have to clean up. It's not okay. All right. I always work on trays. I have lots of different trays. We always work in teams. We always work in teams. I had some helpers there in the class that day. Even they followed their good example and worked only from trays. Okay, put the pieces together. Here we're working. So this little boy is looking at a piece. He's explaining to this gentleman which piece is needed, and she's waiting to put the next piece onto. I don't know what they were building. Looks like they were building Animal Allies pieces. Yeah. All right. But learners do need to take ownership and keep the boxes sorted. All right. The biggest problem is pieces falling on the floor and then just getting swept out the door. That's not okay. Just for you as coaches as well, the brick does need some attention. So it needs to be charged, and I would definitely say keep it charged, like charge it in the morning or before you have it. If you are really working hard with a robot, they don't last longer than 45 minutes with reliable movements, okay? Especially larger robots, 45 minutes is max, okay? And there's a good link there to say if something goes wrong with your EV3 or if it stops working, if it falls, it's going to not work. So that's just a given. But you do need to start removing old projects and make sure the wires are connected and things like that. So it does need some attention, the robot. And then for teamwork, that's not always easy. But you as the coach, you will need to instill with the learners, like who's looking up the pieces, who's finding the pieces in the box, and who's putting the pieces together. They can all work in harmony. The learners, members of the team can all work in harmony. It's possible. All right. So there's lots of useful resources. The one robotics competition we're going to show you now at 4 o'clock is the virtual gear competition. We're very excited about that. It's got open categories, so even the grandma can participate. The first Lego League competitions, they're running at the moment. There are competitions from grade R. There's the first tech challenge, which is for the high school learners. World Robotics Olympiad for all age groups. The other resources that are really useful are building guides, online tutorials, and YouTube videos. Lots. And I share up and every now and again we share some resources, but if you have something that you really find useful, please help us and share with us. Okay. I've highlighted here my Builder Dude 35. Kyle has grown up. He was just a boy in a team, and he has produced some really informative videos. So he's still my favorite. He's written a book as well, so just FYI. Okay. There are guides for all the robots, how to sort them for the robotic sets. They are available. You can download them and use them. There is also virtual robotics options if you don't have a kit yet. Okay. There were some software sessions, and as I'm talking, I wonder whether we shouldn't repeat those again. Maybe in June, I'll do all the different virtual robotics software options. Lego Digital Designer is good for designing, just for designing robots. The Virtual Robotics Toolkit is great because it's got some challenges in there, and it allows everybody to program a virtual robot. The Gears bot is a bit rudimentary, but you can learn to program a little baby robot. I think the important thing is to encourage to build, encourage to design, encourage to program, and all their own attachments as well. Okay, so we'll do another session on this. I think the important thing to know, it's free. Okay, and so here I'm really encouraging you to download the free software salon for tomorrow, and register for the MOOC. And then go and see whether you can find at least one robot that you can build. And if you've got some great videos, you're welcome to share with us tomorrow. Again, if you've got any email queries, please email ISET and let's see whether we can assist you. All right. Let me just stop sharing here. Okay. All right. So on that, sorry, lots of information overload note. Lots and lots and lots of information. Welcome to building robots. Obviously, it's more fun if you build and you build a really cool robot that can actually move. It's even more fun. Yeah. So there we go. Any questions so far? Any questions that you'd like to ask, or information you'd like to share, or something you've thought of? Anybody? Or is everybody in silence? I think everybody would like to build their own robot.
Yeah, unfortunately, I can't see so much from my side, unfortunately.
Okay. Next time. I didn't see any hands. Anybody want to add how long they've been building robots, how much fun it is? Anybody? I think the one thing with building robots is you actually need to build and program and test, and build and program and test, and have a reason why you're building the robot. So build a robot to do some robot missions. So maybe to participate in the virtual gear competition, or build a robot to fetch something or carry something. But I think the important thing is just to build a robot and to actually see it move. The programming classes are normally the loudest. Yeah. But it's always lots of fun. And we are really grateful to have so many new people with us in the group as well. We have to equip our learners for their future. And the sooner we start, the better. The sooner we start. All right. Okay, so if there are no further questions, it's been really great having everybody here. I know Tumelo was going to close the session, but he is in the library. Okay. And then we will see each other at 4 o'clock. Antani, do you want to close the session before we end the recording?
Okay. Thank you, everybody, for joining us today. It was a pleasure hosting you. Can't wait to see you at 4 o'clock as we launch the virtual gear. So from me and the ISET team, thank you and goodbye.
Thank you very much. See you at 4 o'clock. Get some coffee quickly. Thank you, team. Thank you so much. Bye.
Bye-bye.
Bye. See you.